All right. So with that, I'll pass the stage to Joe from X3D HAnim. He's gonna talk about content on HAnim. I'm still like new to the even I myself not sure of the full agenda, but Joe, feel free to take over and pretty much you have the entirety of the session time to go over the content.
Okay, well, my name is Joe Williams. I'm been member of the Web 3D Consortium since 1999 or so, and interested in 3D stuff a little bit before that. I'm going to share what it's going to let me share. Okay, well, this
See a
was
browser.
actually one of the last things I wanted to show, but this is a level 2 HAnim character. Level 2 means that the skin is driven by the uh, joint rotations. Uh, it, if you talk bones, it's the same thing. You just assign the weights to the parent joint. Um, this on the side here shows the user code, okay? And the user code in this thing starts out with the main container, the HAnim humanoid. And that container holds things like skeleton and skin, the skeleton consisting of joints and segments and sites. The this example here only shows, does that show up there, HAnim joint? So it's the sacroiliac of this character, and the name and the center, its joint centers at 0.92 meters. The skin cord index is the index of the joint of the skin vertices that are controlled by this joint. And then the weights there. You can see very simple weights. They're all one on this. There's not a lot of mix up in this. The skin itself just constitutes a minimum, what I'd say is a minimum skin, which is just made up of the defined external surface feature points. And so that the um, surface features are used to make the triangle for the skin. I'll show a little bit more about that if I can. I stopped sharing. Now I'm going to try to share screen again and see if I can get anything else up here. Darn it. Okay, it gave me this one. When throughout the history of VRML and X3D, I see a couple guys from Sony here. Sony very heavily involved in this area here in setting up X3D. Chris Marin, you might recognize his name. Very important member in VRML getting started. Sony started taking a different go on the scene graph and event system and so forth. And so we kind of lost them, but they left a lot of valuable information with there. Through this time, when I first started seeing it, HAnim was kind of composed of three groups of people. There was the performance guys that wanted to have a performance database. And then there were the medical guys that wanted to have something that they could put behind the only skeleton or humanoid that these guys could experiment at that time was behind the wall, and all they got to do is put in a little list of things, a list of joints they wanted to test, and some limitations on it and so forth to run a simulation. And then the third group were artists. They're doing 3D. And within that group, there were kind of two, I'm oversimplifying maybe and crossing, and maybe my memory's not so good, but there were two kind of groups in there. The first group was people that wanted to kind of go for the high end of this medical and a lot of military led NASA, Boeing simulation. And there was another group of artists that kind of wanted to follow in the footsteps of Harry Heiserhausen, and build up from the kind of armature-based animation, uh, motion, stop motion animation. And but the guys that were more involved in VRML and HAnim at that time, totally different projects. The HAnim is independent of the platform. X3D is very carefully tailored with the event system and a lot of kind of different things. Anyway, the HAnim was published as a international standard with a level 1 and level 2. Level 1 is geometry for the arms and legs, like armature for the segments. Shapes for the bones, shapes for the segments. We call them segments. And then then in order to define the thing in the course of HAnim, let me see if I can get something else up here. There's a lot of people, but again, Web 3D isn't leading anything. It's we're just collecting. HAnim collected the best practices through there, and anybody, I'd like to, have a discussion with anybody who don't think the best practice of setting up HAnim is reflected in this specification. And X3D just happens to have a good implementation of it. What's very basic in setting up a humanoid animation is a hierarchy of transforms run from a skeleton. Okay, transforms. Everybody has transforms. And VRML was totally invented to support HAnim and a environment for it. Okay. Did I overdo that, or am I getting okay? Let me see. Try one more. Let me try a share screen again and see what it will do. Doink. I don't need that. Okay. Let's see. I can. Oh yes. How about this? I hope it lets me have this. I hope that was a good story about the origin of HAnim, because there's so many different groups of people involved in it. If you press the button on 3ds Max character generator, press primate button, you get about a LOA2 HAnim character in the correct coordinate system. The coordinate system. Okay, let's see if I can get one of these going here. Can you kind of see this thing going here? This is
Yes.
a complete skeleton with the designated surface feature. What we call them, they're called as sites. You can kind of see the skeleton here. The red are segments. They're connections between the joint centers. And then the site locations are shown connected to the joints that are the primary control of their motion, so that a twist you can see this twist going up the spine here, and then kind of how those sites are connected. So they're this is the basic level 1 humanoid. It's an LOA4 in terms of it's got 136 joints, and it has the 120 site locations, the surface features. The surface features, these sites can be anything X3D. They can be whatever you want. They can be sensors. They can be geometry. It can be anything. But mostly they're points of interface. For the medical guy that says, okay, I want to, in my medical model, I want to have your heartbeat record on this node right here. It's a functional, fully functional database. And when you understand the X3D SAI, it's the DOM of X3D, then you'll see it as a fully functioning event system that's really designed for high-level simulation because it doesn't lose cascades. It's all time and event-based and with strong node and field typing and a very, the animations are performed by simple orientation interpolators, and they rotate the joints. A walk, we can get a nice little walk out of this thing. You guys okay? Am I doing okay? Any feedback?
Yes.
Uh,
Yes. Yes.
Oh, okay.
I have one question. Can I ask you a question?
Sure. Thank you.
So you might have already mentioned, but what are those green points represent? What does these green points?
The green, yeah, these green dots are surface features. They're called sites. They're a child of the segment, which is a child of the joint. So this joint right here is this thing we call a site is a child of that joint. So when that joint moves, it moves. And so it's and it can be anything. It can be an end effector. It can be a transducer. If you're in an environment where you need to push buttons, well, then there's a site that push buttons. It's a way of standardizing the interface points of the humanoid. Now, these interface points were first kind of measured, the history of it. There's a CSAR project. It's an ongoing international project. Now, anyone can contribute and go in and find out what they have. But this was a catalog of human measurements. And so they measured a bunch of humans. And then we picked a reasonable example of it to prove where these sites, like this point right here, we can there's a down in the corner, down the left hand corner, we do a little mouse over to get that. There's a name. It has a name, and that is the skull vertex. And the skull vertex is the official medical name. It's the official name that people in the business use to define that point. And so in a way, the points are just a suggestion. Let me see if I can get another little example up here. Yeah, this is a good example here. This is the Excite viewer. It's an open source viewer, the latest WebGL. This is a HTML page with, this is a canvas, and this is some XML out here for the listing. And so it's, if I change, like, let me see, what can you see that now? Is that still up there?
Yes, we see the character
is this thing running?
A ball.
Okay, yes. Here's an example of an orientation interpolator to drive the mid-tarsal thing. Here, it doesn't really do anything. The coding is axis angle. It's X, Y, Z, or pitch and yaw and roll, and then a scale factor. It's almost there, axis angle is almost like a quaternion, except it's in radians instead of normalized to a unit quaternion. So this one, most of the joints aren't animated, but right here, in this example right here, I'm putting in 0.2 radians of pitch roll. The way that the transforms are set up in a default, then for the default pose, all the transforms are zeroed out, which means they're in this, they'd be in a quaternion would be 0001, I guess. Or it would be anything because the scale would be 0. Anyway, axis angle is just convenient to work with. It's very natural once you get used to it. And so another point in animation of skin here, I hope I mentioned that the scale factors or the weighting, how that's applied to the skin, but also HAnim includes this thing that's called a displacer. And we see the displacer in the head action here. All it is instead of animating a set of vertices using like a coordinate interpolator or something to that effect, we tell it after the skin animation is done through the joint-driven weighting, then we add this function called a displacer. It's actually just a 3D vector from the default point to wherever you want it to go. Here we're just expanding the head there a little bit. And it's just a very concise way of writing it. You tell it which vertices you want included in the displacer. Here, there's just 8 vertices, very simple head on this one. And then you can also see the texture. Can you see the texture rippling there? That's just a texture transformation. It just rotates this particular little texture around. You see flying by there, that's the 000 of the character. And then here's the 000 of the scene. Notice the blue is the z-axis. The humanoid is drawn facing z. The coordinate system is y up, z plus z toward the user drawing the thing. The humanoid is not a mirror, it's you looking back at you. And so the x plus x is off to the model left. Y is up and plus Z is forward. The camera is placed in plus Z. The default camera is plus Z, looking at the avatar. If you want the avatar to have eyes, you have to turn the viewpoint around 180 degrees and put it in the eyeball section. It's just if you look at it and study it, you just find a very well accumulated standardization of what close examination will still find as best practices. Now for animation, it's not going to be unusual at some point that we have a animation AI in their module that figures out what to do depending on what you tell it. And we won't have a setup for the AI will do it until you're happy, and then that's the gesture or animation that you can use. And I don't know what's going to happen in there right now. In order to do an animation, it's normal user stuff is set up for a lot of them are set up with Z up. Now the difference between Z up and Y up is whether it's DirectX or GL. Since the web is built on, the open web our web is built on the GL and all advances on it right now. And right now, this guy right here and this viewer is taking advantage of the very latest ones because it's a JavaScript. There's JavaScript is running this animation. It's running the scene graph. JavaScript's running the scene graph, and thus the animation and so on and so forth. X3D we can import a shape, the index face set, into this. I want to give you a better organized tour of it, but this is another version of that with some geometry. I found that I just use this one. It has a lot of transparency in it, so you can see through it. But this is level 1 geometry. Gosh, you can't see it very well, maybe, but this is level 1 geometry where there's a piece of geometry for this head. It's an index face set that's for the head. There's another index face set down here for the pants and so forth. I should bring one up with the but anyway, and so level 1, this also has can use that displacer animation in here. In other words, you can take sections of the geometry for the head and make that displacer. As a matter of fact, there's even more points than this right now. There's a good effort going on to standardize not only these surface feature points on the body. As a matter of fact, right now, the garment people are working with us to add more of these sites that are used in the garment industry. And so it goes to that in the facial animation, those are also just a set of prime points that serve as anchors to do a displacer operation, which is the most simple. Instead of doing a set of coordinate interpolators or some other kind of morphing to produce an expression. Okay. Well, this is kind of an intermediate point. When guys working on this, John, wanted to take the skin from the kicker that you saw and put it on this kicker. Well, the thing is that that kicker was built for an LOA 3, and this is an LOA 4. So we've got to go through and reassign the control points, the weights, assign the vertices, the skin vertices to the joint, and put in the weight. And so that hasn't been done. So this thing doesn't walk yet, but it all uses the same animation. It's just the skin isn't hooked up to this one. And so I guess that's called rigging a lot of times, where you're taking the skeleton and hooking up either, there's a lot of manual ways to do that. There's sort of one thing I saw, I think it was in the 3G, anyway, it was a perspective skin of something like, 60,000 triangles. Let me say, one of the recommendations of HAnim and X3D is that the thing is in scale. Okay. It is 1.8 meters tall in the environment. And so if you're making but many authoring systems want you to work in size 44 or something. And so then you have to reduce it by scaling to get into a normal one-to-one environment that you're probably going to be working in. And so, but anyway, if there's a host coordinate space, there's the humanoid coordinate space, and then there's this skeleton coordinate space, and then there's the skin coordinate space. And everything is going to work better if it's all drawn in the same coordinate space. That is, if everything's drawn in place. Now, any authoring system that's having any fun, it'll let you draw it anywhere. But when you want to export it to a scene that's built in meters, like a real world might be, then instead of, and we would recommend that that's, that's the way that the geo standards are done. Excuse me, X3D very involved in the geo stuff. Again, just picking up the good stuff, and to an open environment. The reason I skipped over the user code part of it, because it's so important to have a user code, something the user can edit, something he can walk away with. There's no reason, of course, in the old days, now it's easy, there's a lot of transport, but back in those days, the rigging was so important. It was a tightly guarded secret, and man, nobody was going to be able to export that without paying the price. And of course, now sort of loosened up a little bit, and the standards of GLTF, Collada, and so on and so forth, all the Chronos stuff, including the oncoming USD. The USD I really see as that's going to be the metaspace, wherever we're in the metaverse, or wherever we're talking about, it's going to be the browser for that environment. The HTML added images and MPEGs. Okay, and now we can add GLTF stuff, and even as the runtime, the kind of runtime we need. DOM is getting there, over the revolutions. The DOM is slowly become more live and really programmable. X3D runtime is already there, and we can interface with the DOM. SAI talks fine with the DOM in a canvas, and for right now, or run free. Okay. I just want to show you another example of the user code, because I think it's so important. If we look at it, you see there's a giant diagram of how the nodes inherit from each other. So the grouping node, anyway, I could show you that, but here's a shape. The shape turns out to be a line set. It's a piece of geometry. If you looked at it, there's a container on this thing. The container node is called geometry, and that's how this node can't go into the user code any place else but a place where geometry is allowed. And so this is part of the user interface here to select the menu for that thing. So there's a bunch of boxes drawn and so forth. It could be a little more interesting, but let's see. Okay, there's some other stuff. Okay, so now here, this has a bunch of everything. This is a predefined, I just wanted to get back up there. I'm wasting it all, but here, okay, that's that. And then there's, where am I? Oh, boy. Okay. Here's that sacroiliac joint again. Its center is there. Any transform has a center. The default transform, the translation 0, 0, 0. So all we're doing is specifying a center. That means that you have to have a transform that'll where you can recognize the center and rotate around that center. Most authoring system that use bones they hide that joint center as the end of a bone. You have to kind of understand how it's hidden underneath there. And then they don't give you the idea of, in that joint, you can have a segment. And in this segment, you could have a whole shape for a segment, or you could have something that's, in this case, it's a touch sensor that spits out that text and a piece of material in a box. So there's touch sensor over a box, a line set that goes out there to there. Anyway, all these things are children of that shape. And then we have a real site here that has a position. And so again, that's a child of that. And it's amazing how when you just dimension this from 0, 0, 0, put that point in there of the translation, put the translation in there, when it's embedded in this transform, it just works. It's amazing. And so any authoring system can do this, but will they give it to you? You have to take a picture of the hierarchy tree or something like that. Or can you get it out? Well, 10 years ago, you couldn't. The only way you could get out an index face set out to X3D was by exporting it. And okay, they don't want to export. The authoring tools that are making geometries, you're helping make geometries and make HAnim skins or whatever, they don't want to export it. So anyway, and they don't, and besides, most of them are set up for making movies anyway. And so will they give you back the interpolators that they're doing? Well, heck, some authoring system didn't even use interpolators. Some still don't, or just barely getting on there. And so what you get out is this VHF stream of 60 frame keyframes per second, or 25, or whatever the standard, whatever you want to do. And it's good for making a movie. And in that range, you don't care how long it took to render. In X3D, it's real time. So we want to save resources. So do we want a 60,000 triangle avatar? Heck no, we want about 1,000 or 1,500 or something like that. Something that's necessary. If you want to zoom in on something, you want to zoom in on the face, fine. Let's have another piece of geometry for that, fine. Let's do LODs on it. Volume. Switch over to volume rendering. Any of this subdivision surfaces, however. And if you look at the X3D set of nodes, it's real good. Now, think of the early days of VRML. Two main browsers, one out of Netscape, one out of Microsoft. Okay, the one out of Netscape, essentially Sony continued with. The one out of Microsoft, they bought it. They hired one guy and paid off the other. And then any other VRML authoring of that time got bought up. Anyway, there's still, but right now the interest is setting this up as actually the long term. This is the text version for 3D on the World Wide Web for humanoid. I mean, what, well, I don't know. Like I say, there might be some better ideas and so forth. I just want to look at it. But the idea of coming above the GLTF to where it's a human readable set of stuff that's authorable, that's validatable. One of the links that last link is the XML schema. Very important part of it is that we want to have a runtime that doesn't need a bunch of checking. We want to load and run the thing as anyone else does. Okay, but you got to have good content first. And so that's where the schema comes in to do complete type and organization, schema checking. There's the humanoid animation examples archive. I gave another link to a kind of a sidelight of that, something that was some of the people were working on. Here's that Excite playground. You find that very interesting because it is, he's using the latest and greatest Java, JavaScript to get this thing running, and it turned out just fine. This Castle game engine is the one I was showing most of the examples on there. And this is a standalone viewer. It's not a real editor in a lot of senses, but it's a runtime for X3D. And there's plenty of stuff right now. You can work with a text like a notepad, make the thing, load it in, and check it out. This link right here is the X3D part of it. X3D adopted the humanoid animation standard. And you'll notice that these standards are in HTML. Web3D has a special deal. We don't need to publish in whatever that other stuff. This is a web standard. It gets published in HTML. And we've always been able to do that, and makes this specification a lot more accessible and updatable. And we got full, and what the opening, it's not my job here, but join Web3D Consortium, work on the spec, improve it. For example, the joint nodes, it's only a rotation joint. It only rotates on center, where a lot of joints will have an offset. They won't rotate exactly on center. We don't have, you have to, if you want to do that, you have to make a little prototype that with another little something that adds a little movement to the center, if you want to be really true. Or there's joints that don't rotate at all, but they slide. And so a lot of people that worked on this went into robotics. Anyway, thanks very much. And I hope I can answer any questions that you have. And I hope I can show you more at some time when I'm better prepared, maybe. Yeah, but I was pretty well prepared, but I just couldn't figure out how to work the thing. So thank you very much.
Yeah, this is great. Yeah, thank you, Joe. Appreciate all the insights you shared. There's also like comment in the chat. Like we are out of time, so maybe we'll use the recorded time to take just one question, and then we'll wrap it up and move the remaining questions to water cooler. Anyone has any quick question for Joe?
Oh, I put my comment to chat. Please for that. I have no time. I'm sorry about the great presentation, Joe. Thank you.
You're welcome. I appreciate being able to talk to you guys. I'm just an enthusiast. When I retired, I wanted to pick the best web platform. And when you look at the scene access interface and the event system for X3D, you see you can build a very reliable system out of it. And that avatar can be anything. It can be any kind of entity. And it still works. So thanks.
Amazing. Yeah, thank you, Jeff. And thank you, everyone.